In all the previous examples, we relied on graphical and numerical approaches to investigate limits and estimate their values. Now we start to develop tools for computing limits in a precise way. The following properties of limits, called the limit laws, are used to calculate limits of combinations of functions. Assume that limit of f of x as x approaches a and limit of g of x as x approaches a exist. Then, sum and difference law states that the limit of the sum or difference of f and g is the sum or difference of the limits. The constant multiple law states that for any number k, the limit of k times the function f is k times the limit of f. The product law states that the limit of the product of f and g is the product of the limits of f and g. The last is the quotient law. If the limit of the denominator is not zero, the limit of the quotient is the quotient of the limits. We will not discuss the proofs of these laws. However, it is easy to believe that these properties are true. For instance, for the sum law, we observe that if f of x is close to L and g of x is close to M, when x is near A, then f plus g is close to L plus M. To use limit laws, we first need to convince ourselves that the following results are true. For any numbers a and c, the limit as x approaches a of c is c, and the limit as x approaches a of x is x. The first limit is the limit of a constant function c. When x approaches any number a, the function is as close to c as it possibly could be. It is actually equal to c. The second limit becomes obvious if I just state it in words. When x approaches a, x approaches a. We can compute a wide variety of limits using just these two simple results and the limit laws. For example, let's use the limit laws to evaluate limit as x approaches 4 of x squared. Since x squared equals x times x, we apply the product law and get that the limit of x squared equals limit of x times limit of x. Since limit of x as x approaches 4 is 4, we get 4 times 4 equals 16. The next example is to evaluate limit as x approaches 2 of 2x cubed minus 6x plus 4. First, we use the sum difference law to get limit of 2x cubed minus limit of 6x plus limit of 4. Now we use a constant multiple law to factor out 2 from the limit, and then we treat x cubed the same way we treated x squared. We write x cubed as x times x times x and use the product law for the limits. since the limit of x when x approaches 2 is 2, we replace all limits by 2 and obtain 2 times 2 cubed minus 6 times 2 plus 4 equals 8. Here the limit laws are applied step by step to illustrate how they are used. In practice, we take the limit laws for granted and skip the intermediate steps. Notice that in this case, the resulting expression is equivalent to substituting the limiting value 2 into the function. Our last example is to evaluate the limit of a fraction, x minus 5 over 2x as x approaches 1. First, we use quotient rule, then the difference rule in the numerator and the constant multiple rule in the denominator. Finally, we observe that limit as x approaches 1 of x equals 1 to get 1 minus 5 over 2 times 1 equals negative 2. Again, this is equivalent to substituting 1 for x into the function. The reason why in many cases we can just plug in the limit value to get the limit is discussed in the next lecture.